Good morning, my name's Andrew Christie from Peregrine Semiconductor, and I would like to talk about our mmWave 5G solutions. And so I guess for a start I'd like to talk a little bit about the usage cases that we consider with 5G. So we're interested in fixed wireless access type applications and access points for densification of city areas. And when we're focusing on those types of solutions, the first thing we consider is integration. And we think integration for both of these cases is very important because based on the size of the antenna array and the spacing of the antenna elements, it's important to be able to fit as much of the circuitry behind the antenna array. So integration, the more we can integrate in a single IC or in a very compact solution, the easier it is to implement. Additionally, we think from an antenna array perspective, if we can provide a solution that includes the IC and the antenna array, we can simplify many of the interfaces. So this means we can reduce loss, both from the interconnect between the antenna array and the IC perspective, and between the blocks within the RF chain. Additionally, going for higher levels of integration allows us to reduce cost. So once we've taken the decision to integrate, the next logical step is to consider calibration and system calibration. In the case of mmWave 5G, we're talking about more towards a consumer application. We're talking about high density levels for access points. So we could be in the situation where we have access points every 100 meters. And if we start talking about this level of density, then we have to keep costs down. So we think the best way to do this is to have a IC that is simple to calibrate and an antenna array that is simple to calibrate. As this isn't a military or space application, we don't have the luxury of doing a full system calibration of the complete assembly. So our strategy is to make ICs that are very repeatable, very consistent, and can use a very simple lookup table for calibration. This now then allows us to put that onto an antenna array, which then requires a minimal final over-the-air measurement or calibration. The next area we need to consider in our solution is tracking and locating of users. Unlike a traditional infrastructure system, the 5G system has a beam, and so the constraint here is we have to find the users within space. So the way this is normally going to be done is the system will do a background scan, and the scan will identify where users are within space, and it will track their movements within space. So this requires the system to be able to change direction very rapidly, and there's two ways we can do this. The first way is we need the beamforming components to be able to switch beam position very quickly, and we need a digital architecture which allows us to store beam positions in advance and to be able to index through those in a random fashion. So once we consider all of these factors, the final factor is what type of beamforming do we employ? Do we employ digital beamforming, or do we employ analog or hybrid beamforming? From Peregrine's perspective, we believe that analog or hybrid beamforming is the appropriate choice for mmWaves because of power consumption and processing requirements. We believe this will give the best combination of cost, power consumption, heat management, and still give reasonable flexibility within the system. So we plan to bring to the market a range of products which are complete antenna array assemblies which are pre-calibrated and pre-tested and allow people to easily and simply roll out new systems. Thank you.